Welcome back to Kafka Internal's Crashcasts. I'm your host, Sheila, and today we're continuing our deep dive into Kafka consumers. We're at level 2, Jedi Knight, focusing on operational proficiency. Victor, are you ready to tackle today's challenging topic?
Absolutely, Sheila. I'm excited to share my knowledge on this crucial aspect of Kafka consumers.
Great. Today we'll be discussing handling failures and rebalances in Kafka consumer groups. This is a complex but essential topic for anyone working with Kafka in production environments. Before we dive in, let's start with a quiz question for our listeners. Victor, would you like to do the honors?
Of course, here's a brain teaser for our listeners. In a Kafka consumer group with 5 consumers and 10 partitions, if one consumer fails, what's the maximum number of partitions that could be reassigned during a rebalance?
Ooh, that's a tricky one. It really makes you think about how partitions are distributed among consumers. Listeners, keep that question in mind as we explore today's topic. We'll reveal the answer at the end of the episode.
Indeed, it's a great question to get us thinking about the implications of consumer failures and rebalances. Now, before we dive into the main topic, let's quickly recap some key terms. Sheila, could you remind our listeners what we mean by consumer groups and partitions?
Certainly. A consumer group is a set of Kafka consumers that work together to consume data from one or more topics. Think of it like a team of workers tackling a big job together. Partitions are the units of parallelism in Kafka, allowing multiple consumers in a group to read from different partitions of the same topic simultaneously. It's like dividing that big job into smaller tasks that can be done at the same time. Now, Victor, can you explain what we mean by a rebalance in the context of Kafka consumers?
Great question, Sheila. A rebalance is the process of redistributing partitions among consumers in a consumer group. This happens when the membership of the group changes, such as when a new consumer joins, an existing consumer leaves, or a consumer fails. The goal of a rebalance is to ensure that all partitions are being consumed and that the workload is evenly distributed among the available consumers. It's like reshuffling the deck when players join or leave a card game.
That's a clear explanation, Victor. Now, let's dig deeper into why rebalances occur and how they relate to failures. Can you walk us through some common scenarios that might trigger a rebalance?
Certainly. There are several scenarios that can trigger a rebalance. 1. A new consumer joins the group. 2. A consumer leaves the group gracefully, e.g., by calling consumer.close. 3. A consumer fails or crashes unexpectedly. 4. Network issues cause a consumer to lose connection with the Kafka cluster. 5. A consumer stops sending heartbeats, causing it to be considered dead by the group coordinator. In all these cases, the group coordinator, which is a broker responsible for managing the consumer group, initiates a rebalance to ensure that all partitions are properly assigned to the remaining consumers.
That's fascinating, Victor. It sounds like Kafka has to be pretty resilient to handle all these scenarios. Can you explain how Kafka detects these issues, particularly when a consumer fails unexpectedly?
Absolutely, Sheila. Kafka uses a heartbeat mechanism to detect consumer failures. Each consumer regularly sends heartbeat messages to the group coordinator. If a consumer fails to send heartbeats for a certain period, defined by the session timeout configuration, the coordinator considers that consumer dead and initiates a rebalance. Additionally, there's a separate maximum poll interval setting that defines the maximum time between calls to poll. If a consumer takes too long to process messages and doesn't call poll within this interval, it's considered failed, even if it's still sending heartbeats. It's like a safety net to catch consumers that are alive but not making progress.
That's really interesting. It's like Kafka is constantly checking the pulse of its consumers. Now, I can imagine that these rebalances might cause some disruption to message processing. How do we handle that?
You're absolutely right, Sheila. Rebalances can indeed cause disruption, as consumers need to stop processing, release their current partitions, and then acquire new ones. This can lead to a brief pause in message consumption. To minimize the impact, there are several strategies we can employ. 1. Use static group membership. By setting a unique group instance ID for each consumer, we can make them sticky to their partitions. If a consumer temporarily leaves the group, it can rejoin and reclaim its previous partitions without triggering a full rebalance. 2. Implement a custom rebalance listener. This allows you to handle partition revocations and assignments manually. You can use this to commit offsets before partitions are revoked, or to prepare resources when new partitions are assigned. 3. Tune timeout settings. Adjusting session timeout, heartbeat interval, and maximum poll interval can help balance between quick failure detection and tolerance for temporary issues. 4. Ensure efficient message processing. The faster your consumer processes messages, the less likely it is to trigger a rebalance due to exceeding the maximum poll interval.
Those are great strategies, Victor. It reminds me of a team of workers coordinating to handle tasks efficiently. Speaking of real-world scenarios, can you give us an example of how these concepts might apply in a practical setting?
Certainly. Imagine an e-commerce platform using Kafka to process orders. Each partition might represent orders from a different region. If a consumer processing European orders suddenly fails, a rebalance would occur to reassign those partitions to other consumers. Using static group membership, we could ensure that when the European consumer comes back online, it quickly reclaims its previous partitions without disrupting the entire system. Meanwhile, implementing a rebalance listener could allow us to properly close database connections or flush caches before partitions are reassigned. It's crucial to handle these scenarios gracefully to ensure no orders are lost or processed twice, maintaining the integrity of the e-commerce system.
That's a great example, Victor. It really brings home the importance of proper failure handling and rebalance management in real-world applications. Now, as we're nearing the end of our episode, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course, Sheila. The question was, in a Kafka consumer group with 5 consumers and 10 partitions, if one consumer fails, what's the maximum number of partitions that could be reassigned during a rebalance? The answer is 10 partitions. In the worst-case scenario, the failing consumer could have been assigned 2 partitions, since 10 partitions divided by 5 consumers equals 2 partitions per consumer. However, during the rebalance, Kafka might reassign all partitions to achieve optimal balance. So theoretically, all 10 partitions could be reassigned to different consumers during the rebalance process.
Thank you, Victor. That's a great illustration of how impactful a single consumer failure can be. To wrap up, let's summarize the key points we've covered today. 1. Rebalances occur when consumer group membership changes, including consumer failures. 2. Kafka uses heartbeats and polling intervals to detect consumer failures. 3. Rebalances can cause brief disruptions in message processing. 4. Strategies like static group membership and custom rebalance listeners can help mitigate rebalance impacts. 5. Proper handling of failures and rebalances is crucial for maintaining system integrity in real-world applications. Victor, any final thoughts before we close out?
Just a quick tip for our listeners. Always test your Kafka consumer applications under various failure scenarios. Use chaos engineering principles to simulate network issues, consumer crashes, and other failures. This will help ensure your system is resilient and can handle rebalances gracefully in production environments.
Excellent advice, Victor. That brings us to the end of today's episode on handling failures and rebalances in Kafka consumers. Next time, we'll be exploring different consumer patterns, so be sure to tune in. If you've enjoyed this episode, please subscribe to Kafka Internal's Crashcasts and leave us a rating. Your support helps us continue providing in-depth Kafka knowledge to the community. Until next time, may the stream be with you.